Assalamualaikum and hi everyone. Welcome back to our lecture. This is the second hour of chapter 1. There are 4 parts in this lecture. So let's recap all the subtopics in chapter 1. So we have completed 1.1 and 1.2. Now we will continue with 1.3, which is stoichiometry. There are 3 subtopics in 1.3. They are balance equation, limiting reactant, and percentage yield. Let's look at the first one. There are 2 ways on how to balance a chemical equation. The first one is inspection method, and the second one is ion-electron method. At the end of the lesson, students should be able to write and balance chemical equation by inspection method. For inspection method, all reactants and products must be balanced in the equation. The reason why an equation must be balanced is because to give accurate information about the amount of reactants required and the amount of products formed in a chemical reaction. This obeys mass conservation law. In other words, the mass of any one element at the beginning of a reaction will equal to the mass of the element at the end of the reaction. In this general equation, capital A and capital B represent the reactants, while capital C and D represents the products, while small a and small b represents the stoichiometric coefficient of the reactants, while C and D is the stoichiometric coefficients of the products. Example 1 is an example of a combustion reaction. By using inspection method, you have to check that the number of atoms on both sides are equal. First, check the number of carbon atoms. So on the left side, there is 1 carbon, and on the right side, there is also 1 carbon. So there is nothing that you have to change on the equation. Next, check the number of hydrogen atoms. So on the left side, there is 4 hydrogen, while on the right side, there is only 2 hydrogen atoms. So what you should do here is to multiply the number of moles of water by 2. Lastly, check the number of oxygen atoms. So on the left side, there is 2 oxygen atoms, and on the right side, there are 4 oxygen atoms. So what you should do here is to multiply the number of mole of oxygen molecule by 2. So now the equation is balanced. Now let's look at example 2. This is the equation given. There is 1 nitrogen on the left side, and there are 2 nitrogens on the right side. So you have to multiply the number of moles of ammonia by 2. Next, the hydrogen atoms. So on the left hand side, there are 6 hydrogen atoms, and on the right hand side, there are 2 hydrogen atoms. So you have to multiply the number of moles of water by 3 so that the number of hydrogen atoms on both sides are equal. Next, the oxygen atoms. So on the right side, there are 3 oxygen atoms, and on the left side, there is only 1 oxygen atoms. So you have to multiply the number of mole of copper oxide by 3, since now the number of copper atoms have changed by 3. So you have to do the same thing for copper atom on the right side. Now let's double check all the atoms in this equation. So we can see that the number of copper, nitrogen, hydrogen and oxygen atoms on both sides is equal now. That's all for part 1. Thank you.